Hey all, welcome to my channel Hierarchy. In today's video, we are going to see the unique differences between regression, classification and clustering. So before getting into these topics, let me give a short overview about machine learning. If you are watching my video for the first time, make sure you subscribe my channel because in this channel, I'm posting a full AI course from scratch. If you are a beginner to machine learning, AI and data science, it is definitely going to be a changing career point in your life. Let's get started. So specifically, what is machine learning? It is a step-by-step process which is used for data science or artificial intelligence. The goal of data science is finding useful information from data. The goal of AI is to automate a task. So in this, we'll be following a step-by-step process. That step-by-step process is specifically called as machine learning algorithms. It might be used in data science or it might be used in artificial intelligence. Today, we are going to see the foundation of machine learning algorithms, specifically regression, classification, and clustering. So, to understand these categories very clearly, you need to have some basic understanding about data. Let's try to understand them first. Continuous and categorical data. What is the major difference between continuous and categorical data specifically? If you are having a number, in my table data, I'll be having so many columns. If all the columns consist of numbers and in one column which is considered as a target variable, I mean that is the column that I am going to predict. So in such scenario, if I'm having all the columns as numbers and the column that I'm going to predict is also a numerical column. So if my table is full of numerical values, I mean numbers, that is called as continuous data. Now, what is categorical data? Let me make it much easier to understand. If I have categories to predict, in simple words, if my goal is to understand, I have two different images. My goal is to predict if it is a pen or pencil. If my goal is to predict if it is water or sand just by looking into the image or just by looking into the features. I mean, if I have 10 different columns, in the last column that I am going to predict, it is water and sand, two options. In all the 9 options, it's about the quality of what I'm observing. How the soil or sand will be there. It will be like tiny like particles. How water will be there. No, we can't see that. If I'm putting sand on any paper, it should not make any changes. But if I'm pouring water on the paper, it should make it wet. So for every single properties, if I'm creating a column, and finally my target is about predicting if it is a sand or if it is a water. So in this scenario, what is my goal? I just need to figure out from which category my data is. So this simply is called as categorical data. Under categorical data, we do have different types. The first type is nominal data. Simply, all the categorical data comes under the category of nominal data. But ordinal data is something that you need to understand. If you understood this, you can easily figure out what is nominal data. Ordinal data is something, if I have categories that follows a certain order. Maybe your dress size like XS, S, M, L, XL, double XL, triple XL. So it follows an order, right? When categories follows a certain order. The BMI of a person, if it is less than a BMI, they will call them as thin. If it is in between a range of a BMI that we are expecting, then it is called as fit. If it is more than that, it is called as fat. So if my categorical data follows an order, it is a categorical data. If it follows an order, then it is called as ordinal data. If not, it is a nominal data. As a third type, we have something called dichotomous data. What is it? The name itself is quite weird, right? Dichotomous. Let me make it much easier. It is binary. if my categories, this nominal data is just having two types. So the example that I gave you, if it is a sand or it is a water. If my goal is to find if I have an image of animals, if my goal is just to find if it is a cat or a dog, then we do have just two categories, right? So this is called as dichotomous data. I believe you got clarity on the difference between continuous data, categorical data. Under categorical data, what is nominal data, what is ordinal data, and finally dichotomous data. What you need to keep in mind is continuous data is about numbers. Categorical data is about categories. Specifically, if that category follows an order, it is called as ordinal. If it doesn't follow any order, it has so many categories, it is called as nominal. If it just has two categories, it is called as dichotomous. That is something you should keep in mind. Then we need to understand the difference between labeled and unlabeled data. See here. So in labeled data, if my data, specifically if my data has tags and target variables, that is called as labeled data. In unlabeled data, if it doesn't have any tags or target variables, then it comes under the category of unlabeled data. So what does it means? What does it mean when I say labeled here? Let me give you an easy example. If my goal is to find if that dog is a dog and if that image is a cat, if this is something that I have as a goal, I have an image, it might be a dog, it might be a cat, but I need to categorize and figure it out if it is a dog or cat. How will I do it? I do not have the image. Now, in different columns, I have the features of that animal. So, what I have as features is the height, the weight, the ear length, the eye width, the nose shape, eye shape, how they look, the dimensions. So these are all the columns. So based on that, finally I need to figure it out if it is a dog or cat. Now it is clearly given the features and dimensions. And finally the target column, one column that we are going to predict is it a dog or is it a cat? So it has a clear target. Then it is called as labeled data. If I do not have any target column, I just give 4 different images and I want my machine learning algorithm to do the rest. You find what is the unique features and you do the categorization process. So that is called as unlabeled data. In my data, if I clearly give the labels, if I clearly give my machine learning algorithm, this is the target, then it is called as labeled data. If I just give my data to my machine learning algorithm and I am letting my machine learning algorithm understand it and find out what is unique there, what is the hidden pattern inside my data, then it is called as unlabeled data. And the algorithms that I use for working with labeled data are called as supervised machine learning algorithms. And the machine learning algorithms that I use for working with unlabeled data is called as unsupervised machine learning algorithms. Let me add it here. It is supervised and the algorithms that I use for working with unlabeled data is called as unsupervised machine learning algorithms. Now let's get into the goal of this video. What is the unique difference between regression, classification and clustering? Look into the first point. My goal of any regression algorithm is to predict the exact value, the target column which has numbers. Specifically, it might be about finding the length of a floor, or it might be finding the height or BMI of a person, or finding the possibility or probability value, which is a numerical value. Specifically, if my target has a numerical value that changes based on other columns which has numerical values, that is called as regression algorithm. So my output should be a numerical value and my all the columns should have numerical values. In such scenario, my first algorithm that I should get into my mind is regression type of algorithms. So it has the capability to understand how the changes in the columns is going to how it is going to affect my target column that I am going to predict. So this is how basically the regression algorithm works. The second type is classification. So it is more about this categorical. What we have seen in categorical data type. It is about categorizing. If it is a dog or cat. But here in classification, you will be giving the labeled data. What is labeled data specifically? I am clearly giving the features and I know clearly this is the target and letting know my machine learning algorithm, this is my target. Predict this and give me based on the features. So the labels are clear here, the features. The target is clear here. Then in that scenario, I'll be using classification algorithms. In clustering, the goal is finding the hidden patterns or clusters. Cluster specifically means groups. In my group of all data, I am trying to do the category process. I just trying to categorize that. But how I'm doing it? I'm not giving any features. I'm not telling this is the target. I'm letting my machine learning algorithm understand what is unique, what is different. Specifically in this kind of data, the problem is the similarities are high and the differences is very less. But in classification, the differences are high and the uniqueness are very less. So it can easily be categorized. But in clustering, that's not the case. Here, the uniqueness is very less and the similarities are very high. So my machine learning algorithm need to clearly notice that minute differences and understand what is that hidden label. Then it need to put them into different groups. That is called as clustering. The process of putting my data into different groups by finding the minute differences that is hidden in my data. By finding my hidden pattern, that is called as clustering. So it is one of the unsupervised machine learning algorithm, and regression and classification are supervised machine learning algorithms. Specifically in regression, my output value would be a continuous data, the numbers. In regression, it is going to be a discrete. Discrete in the sense, it is going to be a category. It might be any image, it might be come under 5 categories, like it might be 5 types of animals or something, but I know the number of categories. So that is called as discrete. But here in clustering, it is completely unpredictable. It might be clusters, it might be anything. So that is how specifically the clustering works. It is about finding the hidden patterns in my data. So here, when it comes to data type, in regression and classification, we are going to work with labeled data. In clustering, it is all about working with unlabeled data. So this is the basic difference. It's not about getting deep. This is about the basic difference. Let me give you one example for each. So you should keep them in mind. For regression, house price prediction based on the area of the house. Number of rooms if I am predicting the price of the house. So here area is a numerical value. Number of rooms is a numerical value. Price of the house is a numerical value. Then it is called as regression algorithm. Here the features are clearly marked as labels. The target is very clear. So it is labeled data. Let me give you one example for classification algorithm. Email spam detection. The features of a spam email is absolutely it will have some keywords like offers, discount. It will be having some images where it added some keywords, which it has some keywords. So like it will be having so many keywords that is often used for advertisement. So features are very clear and the target is finding if it is a spam or not a spam. So it comes under classification. But what about clustering? Customer segmentation. In business specifically, if you are working under a business or most of the businesses are using these machine learning algorithms. If they want to understand their customers and categorize them, they do not have designed features, designed set of columns to find out which category they are coming under. They'll just give the data to my machine learning algorithm, and that machine learning algorithm will find the hidden patterns. So simply an example, like if you are searching some products and putting them in cart, and you will see some suggestions like frequently bought together. So these are the best examples for clustering. The hidden patterns, because it is not designed for every single user. Most of the user are buying in a different pattern, right? So if you do not like that frequently bought together option, for the second customer they will suggest another product. So by suggesting different ways, they are finding out what is happening. So that kind of algorithms are called as clustering because it finds the hidden patterns in my data. I believe in this video you clearly understood the difference, specifically the basic difference between regression, classification and clustering. Why I am calling it basic is because in upcoming videos we are going to see very clearly how regression works, what are the evaluation metrics, in real life how it is being used with so many use cases, and we are going to see how to code from scratch for all these algorithms, and we are going to solve multiple real life problems. So yes, bye for now. We'll meet you in next amazing video.